Let us perform another experiment similar to the one in the previous section. As we want to concentrate purely on the magnetization, we can leave out the coordinate system. We have two tissues, A and B, which have different relaxation times, as we will see later. We send in a 90-degree RF pulse, switch it off, and wait a certain time, TR long. We will explain later why we use the term TR. Then we send in a second 90-degree pulse. What will happen? As after the time TR long, tissue A and tissue B have regained all of their longitudinal magnetization, the transversal magnetization after the second pulse will be the same for both tissues, as it was after the first RF pulse. Tissue A cannot be differentiated from tissue B. What if we do not wait so long from pulse to pulse? Let us see. After the first pulse, an equally sized transversal magnetization is established in both tissues, which decreases after the pulse is switched off. At TR short, however, tissue A has regained more of its longitudinal magnetization than tissue B. When the second 90-degree pulse now tilts the longitudinal magnetization 90 degrees, the transversal magnetic vector of tissue A is larger than that of tissue B. And when this vector of A is larger, it'll reach closer to our antenna. Thus, the imaginary steam pipe at the tip of vector A will cause a louder, stronger signal in our microphone, the antenna, than vector B. The difference in signal intensity in this experiment depends on the difference in longitudinal magnetization, and this means on the difference in T1 between the tissues. Using these two pulses, we can now differentiate tissue A from tissue B, which in our experiment was impossible, choosing only one 90-degree pulse or two 90-degree pulses that are a long time apart. When you use more than one RF pulse, a succession of RF pulses, you use a so-called pulse sequence. As you can use different pulses, for example 90 degrees or 180-degree pulses, and the time intervals between successive pulses can be different, there can be many different pulse sequences. As we saw in our experiment, the choice of a pulse sequence will determine what kind of signal you get out of a tissue. So it is necessary to carefully choose and also describe the pulse sequence for a specific study. The pulse sequence that we used was made up of one type of pulse only, the 90-degree pulse. This was repeated after a certain time, which is called TR, time to repeat. How did TR influence the signal in our experiment? Here we have our last experiment with tissue A and B, depicted in 7 single freeze frames. With a long TR, we got similar signals from both tissues. Both would appear the same on an MR picture, since the transversal magnetization was the same for both tissues. Using a shorter TR, there was a difference in signal intensity between the tissues, determined by their difference in T1. The resulting image is called a T1 weighted image. This means that the difference of signal intensity between tissues in that image, the tissue contrast, is mainly due to their difference in T1. However, there is always more than one parameter influencing the tissue contrast. In our example, T1 is just the most outstanding one. What is a short? What is a long TR? A TR of less than 500 milliseconds is considered to be short. A TR greater than 1500 milliseconds to be long. As you may imagine, or know already, we can not only create T1 weighted images, but also T2 weighted images, and so-called proton density weighted images. This proton density, which is also called spin density, influences tissue contrast, and can be explained quite simply. Where there are many protons, we'll have lots of signals. Where there are no protons, there'll be no signal. We'll hear more about this later. The point is that by using certain pulse sequences, we can make certain tissue characteristics to be more or less important in the resulting image. By choosing a pulse sequence, the doctor can be compared to a conductor of an orchestra. He can influence the overall appearance of the sound, signal, by making certain instruments, parameters, influence the sound more than others. All instruments, parameters, however, always play some role in the final sound, signal.